Hey, everybody. It's Brian Gilmore of HiveMQ, the HiveMQ community, and of course, the Unstructured Message podcast. If you're watching this, you know we had the distinct pleasure of meeting with Andy Stanford-Clark, who's one of the visionaries and the co-inventors behind the MQTT transport and protocol, something that has become so important to all of our successes in digital transformation, Industry 4.0, and the industrial IoT, and even beyond. So I hope you enjoy. You'll see he's a wonderful human being as well as a brilliant mind. And if you are interested in seeing more interviews like this, more content like this, please like, subscribe, do whatever you need to keep track of the podcast, and we'll try to keep it coming for you. So thanks and enjoy. So, Andy, thank you so much for being with us here today.
Absolute pleasure.
I can't tell you the honor of having you on for the second episode of this. And I know Jeremy is going to be, he was a really great person or a great...
Upstaged by Jeremy.
Yeah, exactly. It was a scheduling problem. Your schedule was just, it was so much tighter than his academic schedule. So, but that was awesome to get to spend time with him. And I think, he spoke so highly of you and
That's a great
what
interview.
you guys
really enjoyed it.
so long ago, right? So again, the idea of this podcast is really for us to, highlight really what is a very powerful and very transformative technology that I think most people don't really understand or aren't aware of. And that is this idea of a protocol which acts as an information exchange sort of module or idea, right? And, I think, if you think about protocols like BACnet or Modbus, and you think about protocols like, HTTP or, any of those, like, I feel like MQTT is much, in terms of its overall impact, is much more along the lines of those web scale technologies, which is really cool. And here we have you, like literally the guy who invented it. I know it was your team and, you're leading and stuff, but like, it would be really awesome to sort of like hear straight from the horse's mouth, as they say, like what was, like, even if you go back before Arlen, before the committees, before anything, what was going on that caused this very first sort of seed of MQTT to sprout?
That's a great question. And interestingly, it didn't involve me. So I was actually living in America at the time on assignment from IBM UK to the US, working on really cool stuff. We were doing all the web infrastructure for sporting events like the Olympics and Wimbledon and Roland Garros and Flushing Meadows, all really cool high-profile sporting events. And IBM UK was trying to lure me back to the UK, trying to find a reason to get Andy home, because it looked like I was going to stay in the US for the rest of my life. And my colleague, Tim Holloway, who was one of IBM's distinguished engineers at the time, he was looking at WebSphere MQ, which was our flagship enterprise messaging system at the time. And he was trying to look at ways to drive more messages into MQ on the grounds that if there's more messages, you have to buy a bigger server and we make more money. And so he started looking at what people were actually using MQ for, and linking applications together in the enterprise was kind of the obvious one. But he found some sort of weird edge cases, and he found a company that was doing publish and subscribe messaging, but for SCADA systems. SCADA or SCADA, supervisory control of data acquisition, so remote telemetry, oil, gas pipelines, energy control networks, that kind of stuff. And he thought, oh, that's interesting, because we had publish and subscribe inside MQ, and he thought, well, I wonder if there's a linkage there. So he looked into it, and he discovered that a lot of people in the SCADA world were writing down numbers on clipboards. They were walkie-talkieing them to a mate at HQ. They were faxing them. Zeros were getting transcribed as eights, ones were turning into sevens, and eventually someone would key this into a computer. And from that point on, it was MQ was looking after it, and it was gospel from then on. But of course, nobody was paying any attention to the hideous journey the data had taken up to that point. So Tim said, well, what if we extended the notion of MQ, as reliable message delivery, right from the edge, from the sensor, might go hoppity hop across the networks, but eventually it hits the enterprise in the DMZ and then goes into MQ and then it's in the enterprise messaging system. That means you'll get 100% accurate data transfer when it's really important, like I've just delivered 2,000 gallons of oil to your oil tank, Mrs. Customer. Now we want to send you a bill for that. Yeah, make sure that's once and once only, a short delivery. So all the semantics of MQ kind of kick in at that point. And he thought that would be great. So let's extend MQ out into the network, the wild network beyond the walls of the enterprise. And he he got started with that, and he met Arlen, and Arlen was actually working with this company that was using this pub/sub protocol with one of his customers, and so he was very excited about the idea of pub/sub messaging for SCADA, and Tim convinced him that getting it into the enterprise was also really important, because this is the whole IT/OT integration between information technology and operational technologies. Often the twain never met. But if you bridge the two together, then of course the business benefits from the operational data and the operational side benefits from the enterprise data. So it's very sort of fruitful union. And so Tim and Arlen together said, this will be great, but we need someone to work on it. At that point, I walked in through the door, hot foot from America, young and enthusiastic, and they said, oh, we've got a great project for you to work on. It's going to involve SCADA systems and remote telemetry, and you might need to get your soldering iron out. So I'm a keen electronic hobbyist, so I was going, right, that's what I'm going to do. That's been my projects when I come back from America. So walked in the door at IBM Hursley near Winchester, my office, and basically took over what was known as the SCADA project for a while, and then working with Arlen, also with Tim in the background, but he was increasingly in the background. Arlen and I decided what this remote telemetry messaging protocol that interfaces with MQ should be, and that was the germ that led to what is now called MQTT. It's called other things along the way, but the MQ in MQTT is because of that interoperability with WebSphere MQ back in the day.
Wow, that's amazing. I mean, to think about like how, I mean, that was quite a while ago. I think a lot of that has changed. I think remarkably, a lot of it hasn't. I think like a lot of, especially on the smaller, the more niche industrial companies, are still doing a lot of things like faxing or writing stuff down or calling stuff in over the radio.
Yeah,
and I guess
back then, and this was late 1998, because I remember that's when we came back from the US. I joke now that some of our customers then couldn't even spell TCP/IP, but that was actually the case, that because people were using dedicated circuits, dial-up lines not with TCP on them, which then ran application level protocols, but they were running raw Modbus or whatever over those wires, literally wire protocols. And one of our customers, it was a company that sold golf course irrigation systems that we were supposed to remotely dial into. And we wanted to move them onto MQTT, and they said, "What is this TCP/IP thing you're talking about?" They literally couldn't spell TCP/IP. They'd never heard of it.
Yeah, those were the days. It's wild. I mean, but I think like even if you look at all the change that has happened between then and now, it is still somewhat remarkable that a lot of companies have not. They know what TCP/IP is now. They know what probably super advanced technologies are, but they haven't really found their way yet to that like democratizing interoperability between OT and IT, like you said. And like I think that's like, if I had like one mission to continue to live my entire life, that'll be it. And a lot of the people that I know, my colleagues, everybody still believes in that so much, because it really is like bringing the wisdom and the information of that OT side into the sort of technological advancement of that IT side, and melding those two is unbelievable.
Yeah. And there were two worlds which could never meet. I mean, the OT guys would say, I'm going to integrate with IT over my dead body. But in fact, Arlen described this really neatly. He said the broker is the demarcation point. He said you've got SCADA data coming in from one side, and you've got the enterprise data on the other side, and it's a bit like a sort of
It's like a barrier. It's like a
body-brain boundary
yeah,
in your head. Yeah,
yeah,
the
exactly.
blood never goes one way or the other. It's sort of decoupled, and it's that decoupling of pub sub, in its purest sense, where the publishers and the subscribers don't need to know about each other or care about each other. So when I publish a message to a broker, that's it, it's all done. I don't know or care if there's 1 or 1 million subscribers listening to 0 even. It might just fall on the floor. And the subscribers don't need to know or care who the publishers are. And the biggest thing with that is that if you just deployed a sensor, as Arlen used to say, nailed to a post in the desert, then and you add a second subscriber application, you absolutely don't want to have to go back to that post in the desert, shimmy up it, and modify the publisher so that it now knows about that second application. The beauty of
Yes.
PubSub is that only the
So I
broker
should
has
fan
to
out.
worry about that, and that's the elegance of the model
That
for
is
remote
huge.
telemetry.
And like I think that whole idea of subscriptions was around, but I don't know that. I mean, I'm trying to remember back to some of the stuff I was doing in the early 2000s, and like it was a lot of point to point, one to one information to destination type integrations as compared to like saying we're
Yeah.
just going to make this piece of information available on this, address and anybody who wants it can have it.
But it was
Um,
very much point-to-point messaging, as you say, and MQ was queue-based point-to-point messaging. But then in the back of the minds of the computer scientists amongst us, there's this messaging pattern which existed in sort of computer science, which was publish and subscribe is another way of doing messaging. And I always used to argue that point-to-point messaging is a degenerate subset of pub sub because you have one publisher and one subscriber, and they just send messages to each other. But so in fact everything is pub sub, and it's just that point to point messaging is just a weak
yeah.
sort of a
Cool.
poor orphaned cousin
Yeah.
of pub sub. So but it seems to fit so naturally into the non-hardwired world. We saw it first in the enterprise that we said you don't want to have to go and modify the source code of your publishing applications just because you dream for another subscribing application to deal with, to process that data in some way. And now these days we talk about data science and analytics. We say adding analytics onto an existing system to monitor the data and produce insights from it. Back in the day, that would to be able to do that, you have to dive into the COBOL code, modify it to send another copy of the data out from the bowels of the application out to this other application. And with contractors moving on and source code being lost, and the guy who wrote the code retiring, all that kind of stuff, that was very, very difficult and expensive to do. Subscribe messaging became a very natural pattern in the enterprise, and then it extended really nicely, even more so in my mind, to the telemetry side because of this thing of not having to go and modify the publishers once you deployed them.
Yeah. It's interesting. You mentioned that brain blood barrier, and like that's oddly exactly how I think about it. But I think I think a lot of people struggle to understand this idea of UNS, and a lot of other people sort of struggle to understand why MQTT brokers are a really good way to look at and approach a UNS. And I think you just nailed it there in that
What's the UNS?
oh, the unified namespace.
Oh, that
Yeah.
UNS. Right.
Yes, that UNS.
Well, I
Wow,
knew acronyms there, Brian.
I know, I know. I feel like I just taught you something. That my life is
Sounds like
complete.
it.
No. But
I'll get you
when
back.
if you look at people like, I mean, Walker, give him his credit where credit's due. Like he was one of the very early people to talk about the UNS, and he was one of the very early people, as I've heard from Arlen, and I hope to have him on the podcast as well. He'll say the first time he met Walker, Walker was like, "This is going to change the world because one, it gives an addressable sort of real-time data exchange, right? Where as long as you know how it's formatted and how it's structured, you can just find the information you need, and taking that information and using it doesn't affect anybody else's ability to take it and use it. And that's very democratizing. And the other thing that he talks about is the the ability to organize the entire enterprise worth of data, both the OT and the IT, through an MQTT broker, and organize it in a way that is logical. The schema just makes sense for the line of business, for the, the business users, for the analysts, the data scientists, all of that. And I think a lot of that comes down to as well, like, I mean, stuff like the fact that you can do bridging in MQTT. You can have multiple topics showcasing the same information, but with a different naming convention. So like you could have like, here's my French topic structure and here's my German topic structure, right? Like, and you're kind of unlimited there. So like, I feel like you guys were super, like, I mean, you basically saw the future, whether it was on purpose or not.
Probably unintentionally, because we didn't really feel we needed a universal namespace, because all of the applications we could envisage at the time were within, sort of on-premise, on-prem as we now say, because no one knows how to say on-premise or what that actually means. But
Or
anyway,
on premises, which
on-premises is the correct
yes,
English. Yes,
those
the
Oxford
Americans
scholars
can't cope with that extra S on the
smack
end.
you around
So
about that.
on-prem implementations where the topic space was very important, and Arlen often used to he'd insist that the first stanza of the clause of the project of the topic was the project name, but he wouldn't put the company name at the beginning before that, because there was no need, because it was purely within the intranet of that one company. So you didn't need to name that it was BP or Shell or Texaco or whatever, but you had to say what the project was, and that was very important. So you didn't get to project A/temperature didn't clash with project B/temperature. But the point you say about democratization, that's really important, because part of the benefit you get from the decoupling of PubSub is also that you've got the semantic richness of essentially not having to express things in terms of tag labels and MAC addresses and all the gawky stuff down on the network. But you can actually refer to things as business objects, as people often, as OPC people would call them. So essentially you've got something which is meaningful to the application writers, which, as long as you design that in from the beginning, and topic space design was a very key phase of any SCADA project or any MQTT project we did for a very long time. And we actually used to say that it wasn't for the engineers to do, it was for a designer. It was like a UX skill to get the information, an information architect involved, because not only would you have to represent a meaningful address space for the data coming off the sensors, but you have to also talk to the application consumers and say, what does it mean to you, this piece of data? And say, oh, we refer to that as this. Okay, that's what we're going to call it then, because the mapping can be done in the depths, whereas you've got the semantic view of it. Basically, essentially, you're moving up the value stack towards the applications, and the higher up the stack you can go before you unleash it means that when people come to write applications from then onwards, then they're going to have a much easier time of it, and therefore the cost of deployment is going to be lower.
Yes. Yeah, I think that's absolutely right. Right. And I now, like, I mean, I was, a control system programmer, and then I was a systems integrator. And now that I'm sort of in this much, more ethereal, like data analytics space, I forget, like, and we'll talk about this later, you already know this, but like I'm really sort of tweaked a bit by the idea of schematizing things too early, right? Because I feel like you never know, and that probably comes from my time at Splunk, like you never know what questions you're going to ask in the future.
Right.
What I forget is that it's not about the analytics and the machine learning, the artificial intelligence use cases that somebody might do in 20 years. It's about, like, how do we quickly and cost effectively, with the minimum number of errors, deploy this job so that it can be used today, but as valuable as possible in the future.
Yeah, well, there's certainly two sides to that. I mean, if you've got all the data wrapped up in a Modbus protocol packet and it's heavily encoded, and you start giving that to application developers, they've got to unpack it. Each time you write an application, you have to unpack it. And if you bring in another sensor from a different vendor that uses a different protocol or a different variation of Modbus, they're going to have to, in each application, you have to have decoders for each different type of sensor you've got out on the network, even if they're the same sensor, different manufacturer. So that was really the biggest thing we wanted MQTT to solve, was that you come off those proprietary protocols as early as possible. I used to talk about sort of keeping the contagion as far to the edge as possible, and then you get it into a common protocol, MQTT, and a common schema format. Now, your point is well made, of course, but as long as you don't throw anything away, there's the question of conversion. So, for example, if you say your Modbus packet contains a IEEE 32-bit floating point for temperature, and you represent that as one decimal place in your JSON payload, you've thrown some of that data away. We used to have an argument, well, not an argument, but we used to have discussions with the auditors, so the people who put the governance, the external governance around oil and gas companies. They say, why do you represent that as 13.1 degrees? And they go, where did it come from? And you can't say, well, we threw it away back in the PLC at the edge. So what we used to do is include the original Modbus string in the payload. So you have all the nice JSON or XML as it was back then, as for the application writers to consume. But at the bottom, in the original binary payload, it would be a binary string that this is what it was. So if an auditor came and said, well, you're converting that incorrectly, then there was a route back to the original data, and that was required for compliance and sort of legal reasons.
Wow.
That was a really important thing for certainly oil and gas back in the day.
Yeah, it's like a data supply chain, right? Because now you have like traceability all the way through, and that. Yeah, I mean, the analyst in me would say, like, I wish there was some way to like go back and correct the errors that had occurred in the past. But I think even like with the way you're saying, you actually could, if you discovered that, like, at some point, as long as you sort of captured as metadata to the actual, payload, all of these different sort of versions, and maybe even like timestamps of those versions, of course.
Yeah, well, versioning of schemas, very, very important. So, well, that's one thing we learned quite early on. Is this version 1 or version 2 of the schema? Because schemas can evolve, and you might add new sensors, you might think different representations. You might see the light and move from Fahrenheit to centigrade, or you might switch to Kelvin, or there might be some reason why, there's that big transition where the whole world switched very quickly from XML to JSON, like JSON. Like, why are we doing all these angle brackets in XML? It's hideous. Let's use JSON. It's so much more elegant.
I know.
We'll move over to JSON. It's just
That's brilliant, honestly, because I think, again, we're talking about like the fact that you built something, again, partially by accident, but I think quite intelligently, that has really satisfied essentially an unlimited number of unforeseeable use cases in the future, right?
I think part of that, the reason for that inadvertent success really was the fact that it's payload agnostic. So we say it's a transport rather than a protocol. So transport is like you take a mailing envelope, you put what you want inside it, you address it, lob it in a mailbox. You don't know or care how it gets delivered to your friend at their address, but the postal service knows it, and they open the package and they get out the thing you sent them, and none of the postal delivery service in between knows or cares what was in that package. And MQTT's flexibility, really, from that point of view, is the double-edged sword of it's schemaless and indeed beyond schemaless. You can say whatever the hell you like. Everything from JPEG image through to ASCII text and beyond. Or structured JSON objects with complying to JSON schema or whatever your favorite schema definition language is. It can be as tight or as loose as you want it, and that's the beauty of it. Now, of course, that's a double-edged sword. The good news is you can send what you like. The bad news is you can send what you like, and the broker's not going to complain if you accidentally miss off a semicolon or a bracket or something in your payload, and it's up to the application to sort that out, unless you filter stuff actively in the network, which of course you can do. But it does mean that you're going to have to make sure that both parties conform to the same schema definitions of what the payloads look like. And that, of course, is what MQTT Sparkplug, which is a layer on top of MQTT, which Arlen's been leading the charge on for the last few years. It's now a standard, seeks to address. It's kind of the bit we deliberately missed out of MQTT.
Got it.
Which is the universal namespace and the schema definitions.
The semantics and the schema all together. Do you foresee like a whole bunch of industry or vertical specific things like Sparkplug popping up, or do you think that people will just start to look at it as like a function of the broker to be able to give you flexibility in organizing, that schema and those semantics in sort of as you please?
Well, up until Sparkplug came along, it was the people got together the very old IT engineering notion of a data dictionary. So you'd have a project or an enterprise data dictionary which defined all the formats and all the schemas that you'd use in your applications. That was maintained completely separately, in a database somewhere, out of band. And it's up to the application writers to refer to that when they wrote an application. But with Sparkplug, it gives you the option for not only a common way of defining those schemas, but also a way for devices to be self-announcing, so that you don't need to go and look up what their schema is. You can ask them, what's your schema? And they tell you, and then you can use that schema from then on. It might even include how do you represent it, what icon do you use to represent it on the screen. So it's very powerful in that respect.
It is.
So it really has filled in the gap. I think we'll see industry-specific Sparkplug schemas, a bit like we used to have the Rosetta Stone, the Rosetta Net for electronic data interchange. Remember EDI, X400 EDI between enterprises? You'd go to Rosetta Net and find out if you're going to send a message to a dentist, you go look at what the dentist schemas were, and you send a message over X400 email to them in the format they could parse.
You give me Wisdom flashbacks here. I don't know.
Yeah, exactly.
Oh gosh, those are the days.
But we still need stuff like that, because you get services on the internet, and you need to have that service discovery. And I was working with a client last year, and they said, "Oh, we need a way of discovering the services which are being advertised." And I said, "Well, you've been there, done that."
Yeah. Doesn't it almost risk turning MQTT into something like BACnet, though? I mean, like that was, if you think about like BACnet, the whole premise of it would be that you had this network discovery mode where you use these BBMNDs and it would fan you out, and then all of the devices that were connected would report back, and then you would send out a request and say, okay, like what's your schema or whatever, and it would send back whatever the model was. But like I think that was a very sort of like poll-based, poll-like exchange, which definitely had its downsides. I had several experiences with BACnet network rushes when people would put like two masters onto the same address and do these crazy internal denial of service attacks without meaning to.
It was Munich, EMS in Munich.
Oh yeah, exactly. Nobody here has ever done that. But like I think like again, like that idea of having that blood-brain barrier of like it's not only delivering the information, but it is telling you at a much higher abstraction layer how the data is organized, what the data means, etc. And then because also those topics can carry, as many data points as you want, as many pieces of metadata attached to those data points, you just sort of like an ask once, get everything kind of model, whereas like BACnet, of course, was very different. You had to keep going back and asking, okay, thanks for telling me that. What is this?
And that, again, is the difference between protocol and transport. With BACnet, you have to do it that way. Whereas transport with MQTT, if you need that level of tightness of interaction, you can do it that way, but you don't have to. If you know exactly what you're going to send, and I've always been a great fan of sending human readable payloads, because you can just eyeball them. If you bring them up there, we had this really nice sort of mind map display of topic spaces that we use as like an oscilloscope when we were debugging applications, and the topics would just start popping up, and you could read what was in them, and that was really attractive. And
Nice.
so yeah, I've always been a big fan of human readable payloads, even at the expense of space. Because, oh, you could have done it in 3 bytes rather than 30 bytes. I could have done, but you wouldn't be able to read it.
Yeah. Yeah, that's interesting. And I think like too, especially if you look at modern technology, like all of what I believe to be like the truly advanced and new technologies, artificial intelligence and all of that, is actually being built and tuned to learn from and consume knowledge that was initially meant for humans.
Yes, absolutely.
Right? You know, so like now we have this situation where it's like almost easier to apply AI or a large language model or vector databases. We can talk about this in at length, to like a very well laid out, very verbose, very self-describing sort of top, network MQTT topic namespace, whatever you want to call it.
We're seeing an interesting example of that now with autonomous shipping. So, as you know, I've been involved with Mayflower Autonomous Ship. So we're now getting to the stage where mariners, human and computer, captains of ships, need to be able to interpret things like what coloured lights look like in the ocean, what the notice is to mariners, which says, "Oh, be careful, there's a rock here," or "Be careful, we're going to do dredging over here next Tuesday at 3 o'clock." These things that come out from the UK Hydrographic Office and other equivalents around the world. How do you word those in a way so that they're unambiguous and readable by both humans and computers in the future, so that human captains can work as well as autonomous ships in the future with all this information without one of them being disadvantaged? Really, really interesting problem.
It is. Yeah, I'm very excited to see the branch of that where they say, well, let's make the computers more able to understand like a human, or something that was made for a human, rather than trying to get humans to understand some semi-structured machine language or whatever. But
Exactly, we'll meet in the middle.
yeah, exactly. That's how it always goes. All right. So, okay, I feel like we've done a really good job of kind of like flailing off into a number of different categories. But like, let's go back again. All right. So, how did Facebook come up in all of this? Like, what was that? I mean, like, we're talking about human to human communications right now, and so you guys spent all this time, energy, and effort to build a protocol that was, or a transport that was helpful for SCADA systems and sensors and telemetry. And suddenly Facebook is like, oh, this will be great to talk to grandma. Like, how did that come about?
Well, it's very bizarre, actually. So there was a company, a little startup, and I can't remember exactly. It was either Octopus or Octopi or something like Octo something, and they'd come up with this phone-based messaging system, and their CTO wrote a blog about how they'd implemented it, and she said, "We picked this protocol called MQTT because they use it for controlling satellites, and therefore it must be really lightweight over the incredibly expensive phone networks that they had back then in the early 90s. No, early 2000s, sorry. So we used that as they implemented their own broker, and they used MQTT from the phones in there. But it was really interesting that actually it wasn't that we used MQTT. If you read the spec for MQTT in the preamble of MQTT 3.1.1, it says that it was used for telemetry over satellites. In other words, for very low bandwidth, high cost networks, for remote SCADA systems. So we didn't say it was used for controlling satellites. It was using for command and control over satellites.
Yeah, which could actually be more critical.
I mean, almost potatoes, potatoes, but
yeah,
you could say, well, she actually picked it for the wrong reason because she misread the sentence. But actually, the sentiment was the same. Anyway,
yes.
so this company built this messaging system, and Facebook bought them and built the broker infrastructure into Facebook's infrastructure, and so Facebook Messenger uses MQTT under the covers, and that's 800 million clients or some
I mean,
crazy.
does it still today? Like, I think like this is one of the big mysteries is whether Facebook Messenger still uses
Well, the
MQTT.
reason way we found out, interestingly, as well as this blog post from the CTO of this little startup company, was that if you look in the credits of the Facebook Messenger app, then Roger Light gets credited, who's the author of Mosquito, because they use the Mosquito client libraries in the Facebook Messenger
Ah,
client.
there you go.
So,
There you
so
go.
Roger very proudly has a screenshot of his credits in this
Does he
in
have the
the.
stock options though? That's the big question.
I hope so.
I hope so too. Well, that's cool. So maybe that's like I think a lot of people sometimes wonder when you come up with this transformative technology, like, do you just commercialize it or do you democratize it? You guys went the route of really going open source, with the Oasis Committee and then the Eclipse projects and Mosquito and all of this. Um, like, what made you guys decide to go that route where anybody could use this idea and this technology however they wanted for
Yeah.
whatever they wanted and do so for essentially free?
So that was really important to me and Alan right from the very beginning. And at the time, it was very counter to what IBM's philosophy was, because our policy philosophy back then was patent everything and commercialize everything. We've relaxed an awful lot since then. We've embraced open source to the max. But back then, I wouldn't be allowed to publish a code snippet on the internet without it having getting the lawyer's clearance and stuff like that.
Damped.
So we might be able to sell it to our clients. If you publish it for free, we won't have the rights to do that anymore. So, but with MQTT, it's really interesting because we'd seen all these SCADA protocols, most of which were proprietary, most of which were arcane, and even the ones that claimed to be open, they would charge $300 or $400 for a copy of the spec. So it wasn't really open. You have to be very dedicated to
Like
it. And then we
shareware
got it
model
like
or whatever.
300-page book, which only the person who wrote it could actually understand. I actually formulated Andy's rule back then, which was that any protocol specification of more than 12 pages can't be implemented by two people in exactly the same way to be 100% interoperable. MQTT was obviously less than 12 pages. But I'd say most of the ones we were dealing with were 300 or 400 pages, and they were just dense and terse and impossible to, impenetrable. And so, and the other thing was the proliferation of protocols. So even within a vendor, they'd use variants of Modbus from one model to the next. So you'd have literally hundreds, and Arlen used to have this chart with hundreds and hundreds of protocols on it, which they had to interoperate between their SCADA systems. And so we said there should be just one more protocol you have to implement on your SCADA system. It's going to be free and open, very sort of easy to, not at all terse. And the main reason for that was because it was a transport rather than protocol, so we didn't have to go into chapter and verse on how you represent a temperature and a pressure and a flow rate and all those things. We didn't care because it's payload agnostic. But the main thing was, the main thing said this is going to have to be in the public domain. This is before the days of what most people knew as open source, didn't know that phrase. So we're going to put the protocol into the public domain so that it's not. You don't have to buy a copy of the spec. It's just free on the internet, and everyone can use it. And that's the way we hope to get everybody using it. So that was our policy from day one. And I had to have some strong words with some of the IBM lawyers to allow me to publish that first version of the spec. But they did.
And we're really grateful you did. I think it's important, for anybody watching this to realize that you can still go to the, to the spec. You can download the spec. You can create your own clients, implement your own code, do whatever you want to do. Create a product in a company like IVMQ did, or
and a broker. I mean, one of the criticisms of the early spec, in fact, probably still a criticism, is that the spec doesn't go into much detail on what's expected of the broker. It's really a client-side specification. Oh, it's actually, no, it's not. It's the protocol, right?
Yeah.
But it was kind of written from the client's point of view, and there was a lot of assumptions made about what the broker would do.
Yeah.
Mainly because when we wrote it, there was only one broker. That was my broker. It was written in Perl. It's quite interesting, actually, because we'd been working on the early drafts of the spec, and we've been iterating them with some clients, some early clients like Williams Energy and Texaco, Chevron Texaco, and Phillips 66, and we've got to put a moment to write up the first version of the spec ready for publication. So I spent a week. I said, right, this week I'm going to write up the spec. So I'm sitting here in my little house on the Isle of Wight in the UK. It took me till Friday lunchtime to finish writing the spec. So I emailed it to Arlen, and he said, great, what should we do this afternoon? I said, well, I'm going to implement it. And he said, great, I am too. So we spent, well, it was a Friday afternoon, ran into Saturday and Sunday, implementing. So I wrote a Perl client and Alden wrote a C client. And then we said, great, let's send the first, a bit like Marconi sending the first message from the Isle of Wight to Newfoundland. And we said,
who's going to relay this?
No broker. Who are we going to connect to? And it hadn't occurred to either of us. We just thought, if we write a client, this will just work. Then we thought, I can go to a broker. So I had to spend the next week writing a broker in Perl. And the Perl broker actually had it's still being used in production today. It's on my home server here. So the Perl broker is a piece of work as once.
But it does work.
It does work, yes. It works very well. And it ran an awful lot of IBM's early infrastructure clients before we had a real broker product. And all the prototypes would use the Perl broker because I could deploy it just like that.
Yeah.
Just push run up Perl.
And anywhere too, right?
And then later we do the proper version with the product version of the broker and so on, which IBM had. Then we had a broker we could sell to people, to clients, and that would then run the workload. Yeah, I remember that so clearly, that sort of oh no moment when we both stood each other. Well, we were lucky, we didn't have video conferencing, but we were both on the phone call to each other. There's like a pause. We've got a broker.
Yeah. That's interesting, and I think like that could be a very sort of important insight to what, like, I mean, we all know like there's a lot of folks on, the internet, LinkedIn, influencers. Walker Reynolds is one of them, Rick Bullotta, and there's a bunch more out there who have very high expectations of the broker, right? And I think what tends to happen there is because the companies that have built the commercial brokers that can handle what you designed is really, like you said, a client specification at very high scale or effectively, reliably, securely, or whatever, securely, rather than hold our feet, the vendors, to the fire in terms of creating features. I think a lot of those requests, like say, for example, sending one subscribe message to subscribe to tons of topics, or like fan outs and things like that, like all of this sort of, getting something along the lines of a spark plug in the actual MQTT spec, like those kind of things. They're looking for the committee, and they're looking for those to be done at the lowest level, at the sort of the basic specification of MQTT. And, it sounds to me like maybe you think that it's not the place for any of that to happen. I mean, like, it really should just be about the package, and then everything upstream should be about how different company, different people, different projects implement it. Is that correct?
Yeah, well, we did add some features in MQTT v5, which were really in deference to people who wanted to build big cloud implementations of brokers, which we hadn't foreseen, distributed architectures. And also some things like adding metadata, not in the payload, but not in the topic, but somewhere in the DMZ in between the topic and the payload. Add some additional metadata tags. But I've always argued that the appeal of MQTT and the fact that it's so popular is the simplicity of it. And I always argue, I used to be the grumpy old guy at the back in the committee meeting saying, no, you must stick to the founding principles. It's got to be easy to understand, easy to implement, no fancy data objects, no serialized Java objects or anything horrid like that. It must be really easy to implement on tiny, Z80 or whatever your favorite, the ESP8266 type device. And anything else, there are ways of implementing those things. So, for example, double publish, so publishing to two topics, send one message to two topics. Well, I'd say, just have an application that receives the message on the one topic you publish to and republishes it on the second topic. And you've got administrative control over that. And the more you bake into the protocol, the more you're sort of, you're putting more, it's making it more onerous for the application writer on the publisher, which is probably an embedded C engineer who just wants to get some data, make a payload, and send it out, job done. So yeah, well, the other thing is that the more you complicate MQTT, the closer it gets to enterprise messaging, so AMQP or OPC-UA or whatever, or OPC-UA, for WebSphere MQ or Kafka, or here's enterprise-grade messaging systems, which all have those rich semantics like transactionality and all kinds of stuff which people pile in there. And we know how big the headers are for those messages, and we know how big the payloads have to be, and we know how complicated the broker implementations have to be in terms of code footprint. And that's not for MQTT. I mean, that's if you want to use an enterprise, if you want to use those enterprise messaging features, use an enterprise messaging protocol.
Very interesting. Do you think somebody could turn MQTT into something more aligned with, Kafka or Pulsar or NATS or Flink or any of those sort of other information exchange protocols? Or is it really just completely designed for a different use case and a different...
No, it's very much designed for a different use case. I mean, the fact that the internet is now gigabit speed and very cheap is kind of a lucky consequence. I still think of connection to your phone or connection to a sensor out in the field as being low bandwidth, high cost to get data from it. And MQTT has to preserve the lightweight syntax in order to be able to support those kind of use cases. And we've seen it. I mean, people do use MQTT for enterprise applications. They're perfectly entitled to, because they like MQTT, they get on with it. They've used it in their Raspberry Pi home automation project. So why don't you use it at work to implement messaging? It's got once it's only short delivery. What more do you need, kind of thing? Especially when people are bringing in data from sensors, they say, well, why not just carry it on? Why switch into WebSphere MQ or an enterprise messaging system? Why not just stay in MQTT right back to the applications? And that's fine. If it does what you want, you haven't got the well, some brokers do, but most brokers don't have the sort of high availability and administrative capabilities that things like an enterprise messaging system would like. So the CIOs tend to be a bit upset about using it, but some brokers, you're only included, HiveMQ, and an IBM's broker as well, and other brokers are available, which are scalable and can have HA configurations and failover and administration, all the things you want. So it's a little bit of a blurry line from that point of view, but that's only because it's simplifying the enterprise use case rather than complicating that's the word, complicating the edge of side of things.
Awesome. Well, cool. Okay, so I think that clears both of those sort of topics up, which is good. And I hope people watch this and sort of understand now quite a bit better, like what this is all about and what it's for. And we have the connectors to connect you up to Confluence and stuff like that, or to Kafka, Confluence, whatever, Confluent, to make that exchange. Like there's the connection between MQTT and WebSphere MQ or whatever it's called today. Cool. All right. Well, just sort of like think about closing up. What do you see as the future for MQTT? I feel like IoT is really starting to hit its stride now. We see a ton of new sort of energy around message exchange within artificial intelligence, of course. We've got space travel. You've got all of these companies really starting to invest in that and think about what communications look like between the moon and Mars, or Mars and Venus, or Earth, or whatever. Like, how do you see MQTT fitting into that future of technology?
Well, I mean, the the good news is that it's stood the test of time so far. I mean, it's the 25th anniversary of MQTT this year.
That's right.
T-shirts prove it. There we go, MQTT 25. So October the 22nd this year will be the 25th anniversary of the publication of the original MQTT spec, which I'm immensely proud of. And we keep finding new use cases for it, and we keep finding things where MQTT is just fine. It doesn't need anything new adding to it in order to implement this use case. And so I think there's several areas. One is you mentioned AI, and I think to me AI and advanced data processing at the edge is really, really important. And as we've got more powerful devices at the edge, the question of whether you process the data at the edge or whether you send it back to the cloud, process it up there, and then send the insight back down to the edge to act on, that we didn't used to have a choice, because the sensors were so cheap and cheerful, or expensive and cheerful, very low capability, that you didn't have the luxury of doing much processing at the edge. So you basically all it could do is gather the data from the sensor, package it up, publish it to the broker, and then let something else in the cloud process that data. So all the data went back up there. But we found that most people were throwing away 99.9% of that data to find the one little insight that they wanted from it. So maybe there's an audio signal. So there's one little beep. Oh, that's the thing we're looking for. And now send the signal back, that control signal back to do something. Now you've heard that little sound. So when you found that one little thing in your data, so we don't need the rest of the data we've sent up. That of course comes at a cost, because you've got to in terms of bandwidth and cost of transferring, and also storage in the cloud isn't free or infinite. So people started learning about that.
You almost never control it either. That's my big fear. You almost never control it either. No. You have much more, ownership of, all of the storage and the processing and the compute and all of that, when it's at your edge or on your own premises.
So if you think about I used to refer to the IKW triangle, data, information, knowledge, wisdom, which is actually a management science thing, but it's data, information, knowledge, and insights. You usually say instead of wisdom now. And we used to say, well, we can send out all the data. If you start moving up that value stack, and you could say, well, I don't want to hear from the sensor unless it's an insight. I want to know that it discovered something it wants me to know about, and that's the thing that's happened. So a bit like my electronic mouse traps in my house. I don't want to hear, nope, haven't got a mouse, haven't got a mouse, haven't got a mouse, haven't got a mouse. We caught a mouse. All I want to know is we caught a mouse. When that time comes. So that's the insight. And with edge processing, especially with AI at the edge, we can do that more and more. And as long as you don't need data from other places to combine with it, because sometimes there's a reason for sending data up to the cloud, and that is that you've got to combine data from not only your sensor, but other sensors as well, plus static data sets from the internet, like weather forecast data or geospatial data or something, in order to create the insights. But if it can be done at the edge, then that's the new model. Don't send the data up to the cloud. Only send it up when you need to tell them something, that something's happened, or to tell other people. And then you can do more and more at the edge. And when, especially that scenario where you're throwing away 99.9% of the data, fine, throw it away. Just create the insight from it, and don't waste any storage storing all that data. So I think that's so the net result of that is that you have less data traveling across the network in modern systems. So, and companies that charge by the byte for sending the data will hopefully feel the pinch there. That's a silly way of arguing for it, because they won't get so much revenue because there's far fewer bytes being sent and far fewer messages being sent as we move more of it to the edge. So one area I think is still the two-way communication. So it's not just sending data. I've talked a lot about publishers sending data from sensors. There's always the return path where the sensor subscribes to data for things like set points or new configuration data or new schemas, maybe. So you just publish using this schema now. So it's very often almost always a two-way street. The sensor is receiving configuration data from other places. So that's one place. And then the other thing is that I'd love to see MQTT in space. peaking. I think having a mesh network between microsats, these little kind of CubeSats that they send up, with an MQTT network between them, I think would just be awesome cool. I did talk to Tim Peake at one point, name drop, and I was
Yeah.
trying to work into the conversation that they should put MQTT on the ISS.
Yeah.
But we actually talked about quantum computing instead, which is a bit random. But
Oh, yeah. Well, I mean, but also very interesting.
yeah, absolutely. Yeah.
What I know about quantum computing is that it's very cold. So,
And hence very cool. Yes.
well, so I guess my takeaway from this is that yeah, we're 25 years in now. We joke about okay, like let's get back together at 50 years, but I don't think that's a joke. Like honestly, I think
Absolutely. No, I was saying this to Arlen the other day. I don't think MQTT is going to go away any soon. I mean, we tracked, in fact, Ian Skerritt, when he was at
Eclipse. Is it Eclipse or Oasis?
Eclipse.
Yeah.
Eclipse tracked the what the protocols used for telemetry devices on the internet, and there was a point in time, I can't remember what it was now, about 6 or 7 years ago, when MQTT overtook HTTP as the most prevalent telemetry protocol.
IoT.
It's not the most prevalent protocol on the internet. Obviously, HTTP is way because
I think in my house we have enough
exactly.
HTTP.
So for devices to use, MQTT came out on top, and things like TOAP very rarely hear about these days. That was a third competitor. So and I don't see anything coming from a technology point of view, either in devices or the server side or the cloud, which is going to suddenly invalidate the raison d'etre of MQTT. It's always there'll always be a place for it. So I think no reason. I'm not sure whether I'll be here then, but this goes in another 25 years' time, and celebrate that because. I remember when SMTP was 25 years old. It's quite a long time ago now. I think, wow, that's been around for ages, almost longer than I've been alive. But I can see how that happens now because those 25 years just slipped by. It's still popular, it's still being used. It's not. It's not.
I think it's barely hitting its stride. I mean, we're just now getting ready. And again, I think it's the stuff that comes next that it'll really get to show its like. You had the foresight to build something that would allow edge devices to send data to central processing where machine learning algorithms, vectors could be created and then passed back down to the device in very self-service, very, as we said, democratized, democratic models. And it's really something that has built you have a protocol, you have projects, you have use cases. Now you have companies. And I would venture to say you almost are starting to see potentially an industry build around this protocol. So congratulations to you, to your team, to Arlen. Thank you so much. It's, I literally can say, I have a job because of what you guys did 25 years ago.
And that really excites me when I see companies that have grown up and exist because of MQTT. And I see even when people are sort of SCADA, embedded engineers for hire, contractors, they say, I only have a job because of what Andy and Arlen produced. But then whole companies who employ people and have buildings like HideMQ because of MQTT. That makes me hugely proud. And it's like, wow, I've actually created an industry.
It's a legacy. That's a legacy. And so few people get to enjoy a legacy like that. I mean, we could go on forever, but let's save it for our 50-year discussion. We should talk before that.
I think we should. Yeah.
So. But anyways, thank you so much for joining again. This was an absolute pleasure, and we'll talk soon.
Thank you, Brian. Great talking to you. It was a great discussion, as always. Thank you.